See, in some of my videos, you have seen the calculation of heterozygosity for a specific gene locus. But in all those cases, I considered two alleles for a gene locus. In such situation, a single heterozygote will be possible. But when a gene locus is represented by more than two alleles, then the number of heterozygotes will be more than one, and in such conditions one can calculate combined heterozygosity. Like in this case, when a gene locus has three alleles A1, A2 and A3 with their frequencies 0.6, 0.3 and 0.1 respectively, and if mating is random in that population, then you can predict the combined frequency of heterozygotes. So you can see what is being asked, that there are three alleles A1, A2 and A3, and due to these three alleles on a specific gene locus, 6 total genotypes will be possible. 3 homozygotes like A1, A1, A2, A2 and A3, A3 will be there, and 3 heterozygotes will also be formed, like A1, A2 will be one heterozygote, A1, A3 will be another heterozygote, and the third one will be A2, A3. So what would be the frequency of these 3 heterozygotes in the population, and what would be the combined frequency of heterozygotes for this specific gene locus that you can calculate. So question is quite simple to understand, that the frequency of 3 different alleles for a gene locus is given, and that specific population is undergoing random mating. So you have to calculate the expected combined heterozygosity. Now let us see how this question will be solved. Frequency of 3 alleles is given here, A1.6, A2.3 and A3, its frequency is 0.1. As I said, 3 different types of heterozygotes will be possible in this population for this gene locus. One will be A1, A2, another will be A1, A3, and third will be A2, A3. And if the frequency of A1 is being denoted as P, frequency of A2 as Q, and frequency of A3 as R, then we all know that P plus Q plus R will be equal to 1. According to Hardy-Weinberg equilibrium, P plus Q plus R will be equal to 1. And the type of heterozygotes, their frequency will be denoted as 2PQ for A1, A2, 2PR for A1, A3, and 2QR for A2, A3. So the frequency of these 3 heterozygotes can now be calculated as, for 2PQ it will be 2 into 0.6 into 0.3, and the other one that is 2PR, it will be 2 into 0.6 into 0.1, and for 2QR the frequency will be 2 into 0.3 into 0.1. So when you will calculate these three, then the frequency of A1, A2 in the population will be 0.36. Frequency of A1, A3 heterozygote will be 0.12, and frequency of third heterozygote, that is A2, A3, will be 0.06. And the combined frequency of these 3 heterozygotes for this specific gene locus will be 0.54, that is 54%. So this way you can calculate the combined heterozygosity for a specific gene locus, which is being represented by 3 alleles.